Let's suppose that we have the sine of the inverse sine of negative 1/2, okay? Now this says I could just set it all equal to the argument of the inside if the argument of the inside is between -1 and 1. How about here? Argument of the inside. Is that between -1 and 1? Sure is. So I could just set all this equal to the -1/2 there. How about part B? We have the arc sine or the inverse sine for the sine of 5 pi over 3. So the inverse sine of the sine of 5 pi over 3. Now, I can say that this is all equal to the inside argument as long as that value falls between -pi/2 and pi/2. Does this value fall between -pi/2 and pi/2? No. That's like what, 1 2/3 of a pi? All right, so what do I do in this case? What I do is I think about the unit circle again, okay? I think about rotating 5 pi over 3. 5 pi over 3 is the same thing as 1 2/3 of a pi, right? So 1 pi, 2/3 of the way to another pi, right? All right, so what reference angles right here then? If I went 1 2/3, how much more to go to 2 pi? 1/3 of a pi or pi over 3, right? All right, so right here, which point am I at on the unit circle then? If I displace pi over 3 here. I'm at the point what? 1/2 comma negative square root of 3 over 2, right? All right, let's see. So I'm going to come down here and I'm going to say this stuff is equal to the arc sine of, what is the sine of 5 pi over 3? What is the sine of 5 pi over 3? Negative square root of 3 over 2, right? Now what does this mean? This means give me the angle whose sine is negative square root of 3 over 2, but that angle needs to fall between -pi/2 and pi/2. So give me the angle that falls between -pi/2 and pi/2, whose sine is negative square root of 3 over 2. Well, that angle would be -pi/3. Let's see, C, part C. I can erase this. I don't want to erase the next one, but I can erase that. C. C, we have inverse cosine of cosine of 11 pi over 6. That's this case, right? Now I could say it's equal to x if this x value falls between what? 0 and pi. Does that x value fall between 0 and pi? No, definitely not. So what do I need to do? I need to do basically what I did over there. Let me draw my circle and let me rotate through an angle of 11 pi over 6. Let's see, 11 pi over 6 is what? 1 5/6 of a pi. So I'm going to rotate 1 pi and then 5/6 of the way to another pi. This is 11 pi over 6. Now, what is my reference angle? How much more do I have here to get to 2 pi? 1 5/6 plus what? Plus 1/6, right? Or I could say pi over 6. All right, so if I'm thinking of a reference angle pi over 6, but I'm in quadrant number 4 here, which ordered pair do I have? Square root of 3 over 2, comma, -1/2, right? All right, so I can say that this is the inverse cosine of, what's the cosine of 11 pi over 6? Here's 11 pi over 6. What's the cosine value? Square root of 3 over 2, right? Now just ask yourself, what is the angle that falls between 0 and pi, whose cosine is the square root of 3 over 2? Well, I'd say that angle is pi over 6. let's suppose that we have this. Find the exact value, our next example. Now, all these right here, it was like the inverse sine or the sine or the sine and the inverse sine. Notice that sine and inverse sine, inverse cosine and sine matched up. But what if we have something like this one? The sine of the inverse cosine of negative 2/3. Notice the sine does not match up with inverse sine. Matches up with inverse cosine, right? So how do I find this? Well, I look at the inside and I say, what is the angle whose cosine is negative 2/3? I don't know. That was not a value I had to learn on the unit circle. So what I do is I draw a picture of this. I say, okay, let's look at drawing a picture of this part right here. And let's focus on the inside part. The angle whose cosine is negative 2/3. Now, if I start out with an inverse cosine like this, I'm restricted between 0 and pi. Now, where do I have an angle whose cosine is negative? In quadrant 1, quadrant 2. Quadrant number 2, I have an angle. All right, so I could say I have an angle with a terminal side like this, okay? All right, now, let's go ahead and say, okay, here's some point right here, okay? This is some point right here. And what do I know about that point? I know that point has an x-coordinate of negative 2. And I don't know what the y-coordinate is, okay? All right, you might be thinking, okay, where'd that come from? Remember the cosine of some angle theta is equal to x over r. So if I have the cosine of some angle as negative 2/3, that means my x value is negative 2, and my r value is 3. So this r value right here is 3, this distance right here. Now, let's drop a line down from this point and make it perpendicular to the x-axis there. So really now I have a right triangle, and this side of my right triangle has a length of 2 units, because we went out to negative 2 to go to that point, right? What is this side of my triangle? I'm going to call that my y-coordinate, same as my y-coordinate. It's the same distance there. And how do I find that y-coordinate? I use the Pythagorean theorem. I say 2 squared plus y squared is equal to 3 squared. So that gives me 4 plus y squared is equal to 9. So y squared is equal to what? 5. So y is equal to plus or minus the square root of 5, right? If I'm looking at it as a triangle, it's going to be square root of 5. So this y value is square root of 5, right? All right, so what am I looking at right here? Okay, here's the angle theta. Here's the angle whose cosine is negative 2/3. I'm really now looking at the sine at inverse cosine of negative 2/3, which is the sine of my angle theta here. What's the sine of my angle theta here? Couldn't I just look at this triangle and use this reference angle that's going to have the same sine value and say sine is opposite over hypotenuse, or the square root of 5/3. Another way you could have looked at this part was sine is y over r. What was y? Square root of 5. What was r? 3. Would have given you the same value, right? Whenever you use this part though right here, make sure you consider the negative or positive. What is the sine function in quadrant 2? It's positive, so I'm good. All right, let's look at B. B. B, what if we have the tangent of the inverse sine of -2/3? All right, so let's identify some stuff real quick, okay? First of all, these two do not match up. It's not tangent and inverse tangent, it's not sine and inverse sine, right? Then what I do next is I try to say, okay, do I know the angle of sine is -2/3? No, that's not one of those values on the unit circle. So the only thing I have left to do is draw a picture, okay? Now, this is the angle of sine, it's -2/3. But when I have inverse sine, I got to consider the restrictions, right? So where do I have an angle between -π/2 and π/2 sine is negative? That would be in this quadrant, right? All right, or the terminal sides, actually, that quadrant, I should say. Here's theta. All right, which point is this? This is the point P. Now, what is the sine of some angle theta? Sine of theta is equal to y/r, right? So if I have -2/3, I know that what? My y coordinate is -2. I know my r is 3. So I don't know what this x is, right? Now let me draw a line like this that's perpendicular to the x-axis right here. This is going to be x right here. This side is going to be what? 2? Actually, at this point, I should have -2 right there, right? But if I'm looking at this as the length of a triangle, it's +2. All right, let's see. I need to find out what x is. How do I find x if I look at this triangle? Use the Pythagorean theorem. X squared plus 2 squared is equal to 3 squared. So x squared plus 4 is equal to 9. X squared is equal to 5. So x is equal to the square root of 5, right? All right, so this x is square root of 5. So if I want the tangent of the inverse sine of -2/3, I want the tangent of that angle theta, right? And I could use the triangle here and say, here's the angle theta prime that'll have the same tangent. If I use the triangle, tangent is opposite over adjacent, so I'm going to say 2 over square root of 5. And let's rationalize. So I'm going to say times square root of 5 over square root of 5. So what does that give me? 2 square roots of 5 over 5. Now from a quadrant number 4, what's the tangent function, positive or negative? It's going to be negative. So there is my answer. 2 square roots of 5 over 5.